welcome to the SSI Orbit podcast, a forum for conversations that explore the ever-growing ecosystems of self-sovereign identity. And I'm your host, Mathieu Claude. Identifiers are a crucial part of our daily lives, and we have private and public identifiers that exist. And so on the private side, we could use examples like social security numbers and driver's license numbers, and there's tons of these private or closed identity systems that manage private identifiers for us, and sometimes they give it to us in the form of cards or tokens or such. And then on the public side, we use public identifiers every day, such as phone numbers, email addresses, domain names, usernames. But the vast majority of all these identifiers, private and public ones, are created and managed by central authorities. And so we can think about governments, financial institutions, telcos, email providers, domain name registrars. And so this centralization means we don't really have ownership and control over our identifiers or perhaps our identities, leaving them vulnerable to fraud and misuse. I was just watching yesterday, actually, a presentation called the AI Dilemma, which is made from some of the same people who made the Social Dilemma documentary on Netflix, which was quite popular. And I'm sure a lot of the listeners have seen that. It was quite interesting. But in this presentation they gave called the AI Dilemma, they talked about how content-based authentication is dead, meaning with certain advances in AI, and they give examples like deepfakes being able to be done so easily now on voice and on video. You could basically perfectly mimic someone's voice with 3 seconds of audio, which is kind of scary with all these podcasts and stuff we're doing here. It would be more than enough content for people to start creating these deepfakes. But it started to make me think about all these like telephone scams that happen, and just thinking about my parents and people that are pressured to send money or do something. And it's just going to become easier and easier to scam people. So all this, I think, kind of is a result of concerns around how our centralized identifiers are managed today. Content-based authentication kind of could fall in there as well. But that's what we're here to talk about today. And this may be an example of something that through decentralized identifiers, or a new way of managing our identities, that we could maybe try to solve these problems. And so there's a growing need for decentralized identifiers that put ownership and control back into the hands of us individuals and enable secure, private, confidential conversations, interactions, and digital identity management. So you've been working in the space, Markus, for many years now in the decentralized identifier space. So it'd be great with this introduction to get an overview of how decentralized identifiers came about. We were just talking about before this conversation that things have evolved over the past few years. So it'd be interesting to see how, just to get a history lesson, maybe to start, how it came about, how it found its way into the W3C, becoming an official standard eventually, and then how things have changed within the past few years, and how all of this fits within the ecosystem of identifiers that we live our lives with today.
Yes, that's all right. All really good what you said. I agree with everything in your introduction, especially what you said in the beginning about how important identifiers are, how identifiers are a basis for a lot of things that we do in the physical world, but and also in the digital world. In our interactions, in what we do in our daily lives, we need ways to name things, to refer to each other, right? We, like you mentioned, some of the examples: domain names, email addresses, social security numbers. So all of these are ways to refer to each other, and without that, we cannot really have interactions or transactions or data sharing or relationships or sending messages for all these kinds of interactions and transactions that we do, whether it's in physical interactions or in the digital world. We need identifiers, we need addresses, and like you said, historically they have often or usually been centralized or managed or created by some kind of authority. I cannot choose my own phone number, right? I cannot choose my own address where I live. It's all these things are, and domain names, IP addresses. There's always a central authority, some kind of hierarchy, and DIDs, when DIDs or decentralized identifiers were first thought of or invented, and up until this day, even there's always been a certain ideological and philosophical component or aspect to it. The way I like to explain it is that at the heart of the question of how identifiers should work is the question of what is the process through which you actually establish a digital identity, right? What does digital identity mean? How do I get one? What's the process through which an identity is established in the digital world? And traditionally, that process has been to sign up in somebody's system or to become a record in somebody else's database, right? Or to get a domain name which is registered somewhere. And the basic idea of DIDs has been to create a process where a digital identity can be established without a dependency on such an external authority, right? That process should be something that I can do completely by myself. And when DIDs were created, or when some people first started thinking about decentralized identifiers, maybe around 2014, 2015, that was also the time when a lot of people were concerned about surveillance and the advertising economy, the Snowden revelations, mass surveillance, all these expressions when we started to say that personal data is the new oil, right? Or when we use social networks, we're not the customers, but we are the products of those social networks. All of these developments kind of led to to a strong interest building an alternative way of how we can establish digital identity in a way that is not dependent on centralized authorities, and the whole principles of self-sovereign identity were formulated, and DIDs were seen and continue to be an approach to try to, like you said, take back control of our data and who we are. To make this a bit more concrete, how did DIDs come into being, or how did people start to work on them? Like I said, I think it happened around 2014, 2015, when the first Rebooting the Web of Trust workshop happened in San Francisco, and also the Internet Identity Workshop, which has been taking place twice a year for a really long time. So in these communities, there were some people, some groups, also the W3C web payments community group, and another organization called xdi.org. So there were some of these groups that got together and started to think about how can we create digital identity, and specifically digital identifiers that are decentralized, and that's how the work began. And then some initial specifications, some draft documents were written, supported also very early by the US government, actually Department of Homeland Security. They also supported this process. And then the first drafts and also first implementations and the first basic ideas like DID documents, DID methods, all these things that we have now started to evolve in those early days.
So we talked about decentralization being a key aspect of DIDs. What are some other key aspects? And I start to think about uniqueness or verifiability, resolvability. Maybe you could help us dive a little bit deeper into some other key aspects of DIDs that set them apart from other forms of identifiers.
Yeah, so originally we formulated 4 main principles or characteristics of DIDs, which I think are still valid, and which make DIDs different from other types of identifiers. And those 4 principles are decentralization. We already talked about that. We can have a whole other discussion about whether or not, or to what extent, all DIDs are actually decentralized. So that's an entirely other topic. But in theory, that one of the main principles is this decentralization and independence from central authorities when the deeds are created and used. Second principle is resolvability. So we wanted identifiers that can be resolved, so that it's possible that given the identifier, you can discover metadata about the subject that the identifier refers to. That is the deed document that contains service endpoints and verification methods that can be used to what we call establish trustable interactions with the subject or the controller, to be more precise. So resolvability. The third principle is persistence. So that means that the identifier, the deed, can stay the same even if the metadata changes, right? So you can update and change this metadata in the deed document associated with the deed. And you can rotate your keys, you can change your service endpoints, but you don't have to change the deed itself, right? So to have persistent identifiers. And the fourth one was to have identifiers that are cryptographically verifiable. This means that when you go through the resolution process, you look up the deed and the metadata, you can, in theory, trust that the result is correct based only on cryptography, and you don't have to trust some third party for using the identifier. All of these are not always 100% achieved, I would say, with all deeds and all deed methods in existence, but at least these have been the four main principles.
We're kind of getting into deed methods. I would be interested in getting your perspective on answering the question, are all DIDs actually decentralized? But DID methods seem to go with the resolvability of them, that when you receive a DID, there's an extension or a resolution that happens for you to get that metadata that's there. Can you maybe talk about how that process works and how it differs with different DID methods? And maybe we could talk a little bit about why are there so many DID methods that exist today? I think just in preparation for this conversation, I was looking through the W3C's, I don't know if it's an official registrar or what, but there's a list in there of different DID methods that exist, and there was over 150 of them now. So maybe we could just talk a little bit about DID methods and how they work, how they differ from each other. Are they all decentralized? And we could perhaps get into the whole conversation of DID docs and resolvability from there.
Sure, I would say DID methods are that's probably one of the most interesting aspects of DIDs, and it's maybe also worth looking a bit back in history of to understand where that came from. The very first drafts and ideas for DIDs did not have the concept of DID methods. So the very first idea was that DIDs could be identifiers that are created in a distributed hash table in a DHT, right? That was one idea for a decentralized identifier. But then some people said, oh, wait, we could create DIDs in a distributed hash table, but we could also create DIDs on the Bitcoin blockchain or other blockchains. At that time, the whole movement or this idea that we were working on was for a while actually called blockchain identity and not decentralized identity, because blockchain was a pretty strong and important topic back then. But then we already realized that there are multiple different ways of how you can create and define how exactly decentralized identifiers work. And so there were some people working on DIDs on the Bitcoin blockchain, and some people were working on Sovereign, and some people were working on Varus1. And then we figured out pretty quickly that we need some kind of abstraction layer, and that's what the DID methods provide, right? So the DID method tells you how exactly you create and update and resolve and deactivate the DID. And this can be very, very different depending on the DID method, right? Originally, again, we thought, okay, there will be perhaps 3 or 4 DID methods, so we can cover all the most important blockchains that are out there. But then it started growing and growing, and we also saw a lot of innovation DID methods that are not based on blockchain at all. did methods like did web that use web servers, did key that only requires a local process. So the did methods are very, very different when it comes to how exactly they work. And that's actually also one of the great features, I would say, about DIDs, to provide this abstraction layer, right? How exactly the DID works is different between DID methods, but the syntax is standardized and the DID document format is standardized. So no matter what underlying DID method or networking technology you use, you can always work with the DID in the same way on a certain architectural level.
It is funny, the influence of blockchain in this space, and seems like it's diverged a bit from each other, where there's perhaps implementations today that still could rely on blockchains, but there's other ones like you described, like did web or did key, and even did DNS, that just doesn't rely on distributed ledgers or blockchains to achieve decentralization, I guess. Back to your earlier comment about, are all DIDs actually decentralized? How would you attack that subject? Or how would one go about, if they're looking at a list of 150, 160 different DID methods, think about, hey, I want to start issuing credentials, or I want to start doing something that requires a decentralized identifier. What direction do I go in? What would be some considerations to look at?
So that's a subject that the DID working group at W3C has discussed for a very long time, and with a lot of passion also and emotion. I remember when first the idea of DID web was proposed, a lot of people, including myself, were quite opposed to having a DID method called DID web that uses DNS and web servers, because by our understanding, those are not what you would call a decentralized identifier, right? If you go to Wikipedia, you look up sucrose triangle, that's this famous pattern or model that sometimes used to explain different categories or different features of identifiers. And by that model, a domain name is definitely not a decentralized identifier, because it is dependent on a hierarchy with a centralized root of trust. And so when DID web was first proposed, there was this very long discussion in the DID working group, and it became obvious pretty quickly that it was impossible to agree on what decentralization really means, because there's just so many different ways of how that can be interpreted, right? Is Bitcoin really decentralized or not, right? If there's a small number of data centers that have all the voting power in a so-called permissionless blockchain, then maybe that's not really decentralized either. And some people were arguing that DNS is decentralized to some extent. And you can look at the technical architecture. You can also look at the governance. You can look at how many different independent implementations there are. So all of these are different types of decentralization. And that's why the W3C DID working group has also published a separate deliverable called the DID rubric document, which is an instrument basically that you can use to evaluate and then compare different DID methods. So it has a long list of criteria, and then you can evaluate different types of decentralization and also other aspects like security and privacy. And then you can evaluate DID methods and compare them, and then maybe decide which one or which ones are best for your requirements, with the understanding that how good a certain DID method is depends on a use case, right? It's not there's not an absolute ranking of these are the most decentralized or the best DID methods. There's also a bit of subjectivity in there. But one final comment I'll make about this is that even if there are some DID methods that are not decentralized, right? Myself, for fun, I worked on on defining a did Facebook method at some point where your Facebook account is your did, right? So technically you can do that too, even if it's very much not decentralized, but technically it's possible to do even that. However, going back to the did methods, again, the fact that you have this construct of did methods, the fact that you have all these different did methods to choose from, that itself is also a form of decentralization, I argue.
Yeah, the whole conversation around decentralization is very complicated. And I think the more and more you deep dive into a specific implementation or something, there are going to be centralization vectors everywhere, like in all these different solutions. It's not like something's completely decentralized or completely centralized. Systems are complicated and some pieces may be more centralized than others. And I think it just comes down to making a decision of what's acceptable and what's not acceptable. And I think to your comment about, you could even talk about some blockchains, and you name Bitcoin being the biggest permissionless, most immutable and secure blockchain, perhaps having some centralization issues around it as well. But one of the things that blockchains do well is that they store transactions or data in an immutable fashion. Whereas there are some other ways of storing data. We could perhaps think of did web or did DNS, where you could perhaps achieve good discoverability of DIDs, and it could be used for resolution, but you perhaps don't get the same immutability that you would get perhaps from a blockchain. And that may be an important aspect to some use cases as well. So it'll be interesting to see how these things play out, or if there's even, you want to use different DID methods as an issuer yourself to just backstop a certain failure or make sure that you're kind of resistant to any things happening. Because like one of the things that's great about blockchains is that like if something's written in the history, it stays in the history and you could always refer back to it. Whereas if something's written to a DNS server and then the DNS server goes down, or the company paying for the domain name goes out of business, you kind of lose that data there. So there are perhaps some other considerations outside of just decentralization as well that need to be considered when making a decision.
In the DID standard, the operations that you can perform with a DID are called create and update and resolve, and then not delete, but deactivate, right? So initially at some point, the operation was called delete, but then the working group realized that many DID methods are based on blockchains and you can't really delete anything there. So then it was called revoke, and then it was called deactivate, and that's what the standard says now. So instead of deleting a DID, you mark it as deactivated. That works very well for blockchain-based DID methods. You just write another transaction to the blockchain that says this DID is now deactivated. And you can still resolve it, right? And it returns a bit of metadata that says it's deactivated now, but you cannot really delete it. With some DID methods, of course, like DID web, you could delete it, and then it's not resolvable anymore. And you couldn't tell the difference of whether or not it has been created and deleted, or if it had never been created at all. So there's some DID method specific differences. But some of the features that or characteristics that blockchains provide are modeled in the DID, are reflected by certain choices in the DID standard, like this deactivate operation, also the ability to query DID documents at a specific point in time, right? So when you resolve a DID, there are DID parameters that you can send to the resolver to look up, for example, the DID document at a specific point in time, and that also works very well with immutable ledger-based methods.
So we seem to have been talking a lot here about public DIDs and ones you would want to go and resolve it somewhere, and we'll get into the whole resolution and the document conversation shortly. But over the years, there seems to have been some advancements in the way we look at the decentralized identifiers altogether in a public sense versus a private sense. And even recently been hearing a lot about autonomous identifiers that are able to be created by yourself. They don't necessarily need to be stored or anchored anywhere. And you're able to still get that cryptographic verifiability and perhaps some other properties of it as well. So how would you look at, if we look at decentralized identifiers, there's maybe different branches under it for private, public use cases, or self-certifying or self-attesting use cases. Could we break that down a little bit more?
So the DID standard doesn't really distinguish between public or private DIDs, right? That has to do with how certain DID methods work and how you use DIDs in what kind of applications or protocols. On the DID layer itself, there is not really a category between public or private DIDs, but there are certainly some DID methods that you could maybe consider private in the sense that you create the DID by yourself and nobody else can see it unless you explicitly share it with someone, right? That, for example, DID peer is a method that was developed as part of the DIDCOM V1 protocol, where the idea is that I create a DID using the DID peer method and you create a DID using the same method, and we exchange these peer DIDs and we establish a DIDCOM connection, and then you could consider that a private DID because you have my DID and I have your DID, and they are pairwise. So for each connection, I create a different one. So only you and I can see each other's DIDs, and then you can do some very privacy preserving interactions and communication. So the similar category or similar DID methods, I would say, are DID key or DID JWK, where the DID itself is basically just a public key. And in that case, if you create these pairwise key-based DIDs and you share them selectively, then I guess that's what you could call a private DID. And also carry, I would say, for example, goes in the same direction, and it's a technology that has received a lot of attention recently. It's another type of identifier technology that you could use in a private way. So this whole distinction between public and private identifiers, in my mind, has to do with the identifier technology itself, and also with how you use them, how you share them.
For private interactions, would a DID be an overkill? Like you mentioned, the DID JWK is basically just a public-private key pair, and there are different types of, a lot of different types of interactions that exist today that just rely on these public-private key pairs. It seems like the decentralized identifier, like one of the big powers, is the resolution of it. And so when you look at different DID methods that are basically just, I don't know if I'm if it's just a fancy way of being a public-private key, do you think a DID is necessary in these use cases?
It's not strictly necessary, of course, but I would argue that even in those cases, if you just work with DID key or DID JWK or just with key pairs and you don't need blockchains or DNS or anything like that, I would argue it still has some value to build on top of the standardized DID syntax and the document data model for interoperability reasons, right? Because you have this resolution, even if resolution in this case is just a very trivial local process, but you still then have a standard way of expressing the identifier, of storing the identifier, and of modeling the metadata, the public keys, and you never know. Maybe you're writing your application now and you think, oh, you will just need one key pair, but maybe tomorrow you will consider other types of identifiers to be more interoperable, and then I think it pays off to build on the abstraction layer that it's provide from the beginning.
If we move back towards, let's call it the public DIDs, or where you are going to resolve to a DID document that is sitting elsewhere than somewhere local. How does this whole process work? And maybe before getting into the resolution part of things, which is quite powerful, we can maybe talk about what a DID document is. And you talked a bit about a couple of things that could get stored in DID documents earlier in the conversation, such as service endpoints and authentication methods, but maybe you could give the listeners a bit of an overview of a DID document, what's in there, maybe under each one of these kind of fields like authentication methods and service endpoints, maybe some examples of what could be put in there, which makes it really powerful.
Right. So on a high level, the DID document contains metadata that describes the subject and that makes it possible to interact with that subject or with the controller. So that's also maybe important to explain that the DID describes or references a subject, which can be an individual or an organization or a thing or really anything. And then a potentially different role is the controller, which is the entity that controls the DID and the DID document. This is often, but not necessarily, the same. And the DID document contains this metadata that enables interactions, secure interactions with the controller, to be precise. And this kind of metadata, essentially, it contains two important things. It contains verification methods, we already mentioned. These are most of the time public keys, and that's what enables authenticated and encrypted confidential communication, because you can encrypt messages, you can authenticate messages. Also other payloads, other type of data like verifiable credentials, right? When a verifiable credential is issued, let's say by a university to a student, then that verifiable credential contains the DID of the university, and often, not always, but often also the DID of the student. And then you can resolve the DIDs to the DID document, and the DID document contains the public key, for example, that you use to then verify the integrity of the verifiable credential, right? So those verification methods, that the public keys in the DID document, are maybe the most important part of that DID document, because that's what enables you to verify that a credential was really issued by that issuer, or that a DIDCOM message was really signed by a certain entity who you have a connection with. So this is what enables what we call a decentralized public key infrastructure, right? Public key infrastructure, so that you can create authenticated, encrypted, trusted connections and interactions. That's why the DID document contains public keys. And the other thing we mentioned in the DID document is service endpoints. Those are basically URLs that point to services on the web, right? So this could be some kind of personal data store. It could be a decentralized web node. It could be a DIDCOM endpoint. It could also be a URL associated with any other protocol like XMPP or ActivityPub, Mastodon, any kind of protocol that you can use to interact, to send messages, to establish a social networking connection, to request data, or basically endpoints on the web used by different protocols. You can also discover that from the DID document. And these two things together, the verification methods with the public keys and the service endpoints, that's really what are those are really the ingredients that you need for trusted digital interactions. So those are the most important things, I would say. The DID document can also contain a few other things. It can contain a field called also known as, so that's something you can use to express the fact that multiple deeds may refer to the same subject if there are other deeds. And there are also various extensions. So the deed document is also an extensible format. You could, in theory, you could put a lot of additional information in there. However, most of the time the intention is, or the idea is, to keep the deed document as small and as minimal as possible. So you should not put your name or your date of birth or your social security number into the deed document. You could do that, but it wouldn't be a good idea for privacy reasons and immutability and all of these things. So the deed document should contain minimum amount of data that's needed to then engage in interactions using other protocols, and then using those other protocols you can exchange whatever data and whatever other information and messages that you want.
And I assume to be able to read the contents of the document is typically publicly accessible, but you won't know which DID document to look at unless you're told by the other entity that you're interacting with of where to look, by mapping it to, I guess, their DID. We
sometimes get the question whether there's some kind of authentication involved in this DID resolution process to look at the DID document. We get the question, can anyone see the data that's in the DID document, and should there be some authentication? And some people, I think, have tried to implement a feature like that, but generally speaking, the DID document is the DID document is considered to be something that anyone can look up if you have the DID, right? So if you tell me your DID, then generally speaking, I will be able to look up the DID document. If you print your DID on a business card, or you attach it to an email signature, or you spray it on the wall as a graffiti somewhere, then anyone can look up the DID document in a similar way how you can resolve domain names to an IP address, right? That doesn't involve authentication. You can just look that up, and that's also the idea of DIDs and DID documents, generally speaking.
The idea of a city with a bunch of graffitis with DIDs on the walls is funny. Basically, within a DID, you could extend, like, we often, when we're talking about DIDs in this space, like, we're very often talking about verifiable credential exchanges, which you kind of mentioned that you're able to use the keys in here to authenticate, or to gain verifiability, I guess, on the signature provider of a credential. But you also said, like, you could also, through the service endpoints, it seems like it's pretty endless that you could point to different types of servers, and the more and more that these are protocols, the more and more you could really continue that whole interoperability story. So maybe I'm doing a credential exchange with someone, and that's the way, I guess, I've been thinking about it, is you could be doing different types of trust tasks between two entities that are connected through DIDs, and maybe we start with a verifiable credential exchange to authenticate one another, but maybe then we extend into a different type of protocol for messaging, or for social networking, or for payments, or the list goes on and on. So do you see DID documents as really being the central point, I guess, where between a public DID and any other entity interacting with it to kind of engage in further trust tasks or further types of interactions?
Absolutely, yes. I think that DIDs provide a basic low-level mechanism for what you could call cryptographic trust, or technical trust, maybe. But then the next thing you can do is exchange verifiable credentials. You mentioned that, so to perhaps start creating some human trust, or to learn more about who is behind the DID. But I would say that's also just a foundation, or a basis for potentially many other use cases and applications and services. You could use DIDs as a basis for existing applications, services, but add trust to those, right? So you could build a social network. You can build. You can play chess, right, over, let's say, a DITCOM connection. You and I, we could play a game of chess, but we would know who the other player is. We would be able to authenticate cryptographically using DITs, but also using verifiable credentials, prove something about each other, and then play chess, right, or go shopping, or rent an apartment, or really any kind of interaction, including social networking, or any use case where we use just plain key pairs today. Another thing some people have worked on is, for example, as an administrator, IT administrator, to log into servers, right? We all, or many of us, are familiar with the process of logging into a remote server using SSH, the SSH tool. You could do something similar with DIDs and verifiable credentials. So you could log in with your DID, or you could set up a policy where you say anyone who is able to present a certain verifiable credential that says, for example, that you work for a certain company, you could then log in to a server using SSH, right? Because DIDs have public key infrastructure built in, and in my mind, anything that exists today that is built with cryptographic key pairs, also encrypted emails, for example, and anything like that could be made better and more trusted with DIDs and verifiable credentials.
Do you see them as more of a disruptor or more of a complementary piece to traditional infrastructure that uses cryptographic key pairs? Like if we look at, we started the conversation talking about decentralization and where there is centralization today with identifiers, and one of those, I guess an example there would be like certificate authorities on the internet today. Do DIDs become more of a disruptor, or do you think more of an enhancer for these existing businesses? How do you look at all that?
It's a really interesting question. I think it could be either way. In a certain way, DIDs are meant to be disruptive or an alternative. The existing CA model, the existing model of having a trusted list of certificate authorities, DIDs have been designed with that in mind, to try to build an alternative to that, where you have a decentralized public key infrastructure where different trust models can be established that are not so centralized. So in that sense, DIDs are designed to be disruptive. On the other hand, they can totally also be complementary to existing infrastructure. There has been quite a bit of work by different groups also to try and figure out how DIDs can be used with traditional X509 certificate infrastructure. And it's possible, for example, to link a DID to an existing certificate issued by a traditional certificate authority, to try to combine maybe some of the best of both worlds. Not sure. So you could have a DID that is fully decentralized, but that still can be connected or discovered from an existing X509 certificate issued by a traditional certificate authority. There have also been some efforts to create an X509 DID method, right? So that would mean that a traditional certificate issued by one of these traditional certificate authorities could itself be considered a form of DIDs. So this question can be answered both ways. On one hand, DIDs are designed to be better than some of these existing systems, but on the other hand, there are certainly also ways how they can be bridged or mapped back and forth.
I think we'll interact with all different types of systems. I think it just comes down to having the choice and the ability ourselves to pick our identifying method. versus being forced into one. But then whether or not we're interacting with an X509 system, or we're interacting with a DID web or a DID SOV or DID Facebook, it really comes up to it's up to us. Is there linking, like in your example of linking a DID to an X509? Do you just have to link on both sides? Like if you have a 509 certificate, you need to have some reference to a DID or a DID document, and then within a DID document on the other side, you need to have a reference to this certificate to provide that authentication both ways. Like how would this referencing work?
It depends a bit on the use case. There are a number of different concrete implementations that have been explored. Yeah, you can do both, right? In the DID document, you could have the X509 certificate. If I see a DID and I resolve the DID to the DID document, and I find the service endpoints and the verification methods and the public keys, then I can also see then that one of the public keys in the DID document is included or is considered trusted in an X509 certificate. Then I can potentially tell and verify that this is not just any random DID and I don't know anything about it, but I could actually tell that this is the DID of a university, for example, because I see the trusted certificate in the DID document. So that can already be quite useful in some situations, because DIDs by themselves are considered trustless, right? So maybe it's also important to mention that, because since DIDs are designed to be decentralized and not issued by a central authority, that also means that I could create 10,000 different DIDs if I want, and you don't really know who is behind that. So having an X509 certificate inside a DID document could be useful to quickly and easily establish some trust in the DID. But you can also go the other way around, right? So if you have an X509 certificate, you start on that side, then there are certain fields in this X509 data format where you can have alternative names. And so you could include a DID inside the X509 certificate, and then you start with a trusted certificate, and you're able to discover a DID, which you can then use for further interaction using DIDCOM or OpenID Connect or verifiable credentials. So it depends a little bit on the use case, on which side you start. You don't necessarily have to do it both ways, right? So I wouldn't say it has to be. I don't think you have to have the certificate in the DID document and the DID in the certificate. Having it one way can also be useful, but it depends a little bit on the exact scenario.
So having talked about DIDs, having talked about DID documents, we've talked about DID methods. One of the areas that it would be interesting to maybe dive a little bit deeper is the whole DID resolution side of things, which seems like the resolution process is dictated by the DID method, which tells you kind of how to begin the process. And with all these different DID methods that are existing and more of them coming, one would think that the resolution process doesn't get easier. How has DID resolution evolved? What are current projects that exist in that space, and either open source, interoperable, even privately managed? I know you are doing tons of work in this space and have products here as well. So I think you're the best possible person to talk about all of these subjects in this specifically. But how does DID resolution work? How does it remain interoperable? What are maybe some of the complexities in this space? It would be great to hear a bit more.
Yeah, that's definitely one of my favorite subjects. Probably what's most important to understand, I think we said that already, but just to mention it again, is that the DID resolution is not one single protocol, right? It's not like DNS resolution or domain name resolution, where there's one client server protocol and you implement that and you talk to servers, and then you resolve the domain name to the IP address. DID resolution is very different insofar as it is also an abstract interface and an abstract function. And how exactly you go from the DID document to the from the DID to the DID document, how you look up the DID document, as we discussed, depends entirely on the DID method, and is very different for each DID method. In some DID methods, the DID document is actually stored as a file or in plain text somewhere on the web server or on a blockchain. So in that case, process is relatively easy for the resolver. The resolver just has to go and get the DID document. It still has to know where to go and how to get the DID document, get it from a web server or from a blockchain. But in that case, the DID document is already present somewhere. But in the case of many other DID methods, the DID document is more like a dynamic virtual data structure that the resolver has to assemble itself in a deterministic way during the resolution process. That's the case with the DID key or DID JWK or some other DID methods, and there's an endless variety of approaches in between, right? So what matters is that the DID resolver has to know for the given DID method how to go and get the DID document, and that's what resolvers do. And resolver is the piece of software or hardware that implements this process for one or more different DID methods. And there are also many different implementations and many different forms of those resolvers. A resolver can be implemented as a hosted service, as an endpoint. That's what something that we have been working on for several years in the form of the universal resolver, right? That's a relatively well-known project in the community at the Decentralized Identity Foundation. So the universal resolver is a service that anyone can run themselves. So it's not a centralized platform, but it's a tool that can be deployed as a service, and which can then resolve DIDs across different DID methods. So it has a lot of plugins for resolving each DID method. And that's something about DID resolution that I think will never go away, right? That there will always be a need to implement each DID method separately, to implement the DID resolution process separately for each DID method. That's a feature. That's not a bug. That's the whole idea of DID methods. And this universal resolver is one example of an implementation of the resolution process that supports many different DID methods, but there are also other open source projects and products and initiatives, code bases like DIDKit or like Veramo, several others that can also resolve DIDs, and some of them are not hosted services. Some of them are local libraries, which is of course better for decentralization, right? So if you resolve a DID key identifier, you shouldn't have to use a remote service. Then in that case, the DID method and the DID resolution process, all of that is just a very trivial local process. There are many other things that could be said about DID resolution. I mean, DID resolution process can returns the DID document. Obviously, it can also return metadata about the DID document and about the resolution process. For example, when was it resolved? What is the timestamp of the DID document when it was last updated? So some additional information can be returned. And then there are also additional inputs that you can potentially submit to a DID resolution process, right? You can pass parameters to resolve DIDs at a specific point in time. You can pass parameters to a resolver to select a specific service endpoint or to transform the public keys to a format that you like, such as base 58 or JWK. A resolver could implement caching functionality. A resolver could implement some security or validation functions. So there are a lot of potential additional things that a resolver can do. But the core function is to take the DID document and to take the DID and to return the DID document. In terms of the current state of it, DID resolution has been out of scope for the DID standard that's been worked on at W3C, or to be precise, the abstract interface, the inputs and the outputs, and the interface for DID resolution that has been defined in the W3C DID standard. But some of the details, how the algorithm works, what a resolver takes as an input, what it can return in more detail, that has been described in a separate specification, the DID resolution specification, which is a work item in the W3C credentials community group, not in the DID working group. But also some of the very recent developments are that there's an effort now to create a charter at W3C for a new DID working group, which could then also work further on an actual DID resolution specification to basically define a lot more details about the resolution process.
Yeah, it obviously seems much more closely tied to DIDs than a verifiable credential would be, because on the verifiable credential side, we're just talking about a specific trust task, I guess, that could be done in different ways. And I guess people that are using DIDs and have a requirement for DID resolution, I guess it really comes down to their use case as well, of which DIDs they need to resolve or they need to support. So I'm assuming that someone that's running a decentralized identity system is going to make some choices of the DID methods that they want to support. They don't necessarily need to support the full list out there. And the more and more I look at the list of DID methods, it seems like the more and more it's just individual companies are creating their own DID methods for their own proprietary systems. So not necessarily sure that there is going to be a need to support thousands of DID methods in the future by universal resolver, unless you think otherwise. But it'll typically come down, I guess, to the use case. And you mentioned some examples of additional functions that you may want to do some translation of certain fields or stuff. So it seems like there is a lot that will be driven by different implementation needs, I guess. Like you have a core, but then around that, it'll be interesting to see how people want to adapt it.
Yeah, and I agree. Definitely not everybody has to support 200 DID methods. It's a completely valid and legitimate approach in a certain use case to maybe just use a small number of DID methods. There are many projects, I think, that just use DID web for organizations and DID key for individuals, and you already have everything you need, right? And you don't need any of the fancy blockchain-based DID methods and so on. But so there's maybe a trade-off or a certain conflict of interests, right? On one hand, if you have a use case that you want to solve, then maybe it's easiest for you or for your startup to just pick one DID method and work with that. But on the other hand, there's also an ever growing interest in interoperability across different ecosystems, and that there will also not be a situation where the whole world will just agree on one DID method that everybody will use, right? So I think there will not be a need for 200 DID methods or thousands, but there will also be more than one or more than 10, maybe even, that many use cases will want to be interoperable with. But it depends. Yeah, it depends. It is maybe a sometimes bit of a difficult situation to decide which DID methods should be used and should be supported. So you also don't want to create a new central authority, right? That officially approves the DID methods that have to be implemented, and so that would also violate again the principles of decentralization. If there was just one way how DIDs work, then of course everything would be easier, but it would to some extent also defeat some of the ideas of DID. So it's a bit of a trade-off, and we'll have to see how that plays out.
Yeah, the only property that I'm still unsure about is, like we talked about it earlier, with immutability, that you maybe want to have a more decentralized store, and you could look at blockchain or something like that. But if it really comes down to, like, you need to have discoverability so that you could then resolve and get the information, or get what you need. And if that could be done through a DID web, then fantastic. I think the only other piece that, and it gets more into like a governance conversation, is like the authoritativeness of data, or based on your context and your use case. And that's where, like, I see some deployments that are using like permissioned or private blockchains, and they're used for discoverability and resolvability of DIDs, but they also kind of have governance or authoritativeness baked into the network because it's so closed in. So if you're using it, then you know that, hey, like, there's only certain entities and are able to issue certain credentials if we're talking about a credentialing use case, and I kind of trust the governance in there. But then if I look at other blockchain systems where basically anyone could write anything to the blockchain, and then it becomes almost like a garbage in, garbage out scenario, and I'm not really getting authoritativeness, and I'm only using a blockchain for discoverability and resolvability, then do I necessarily need to put it there? Is it maybe overkill to put it there and not put it on a DNS server or on a web server, unless, I guess, you have needs for traceability and immutable history and stuff like that. But that's been kind of an area that's been interesting for me recently to think about, like, especially that a lot of us come from the blockchain space, and it's kind of been forced into here. The more and more you go deep, you start seeing that maybe in certain areas it could be too expensive or overkill for what you actually need.
Yeah, and the last 1 or 2 years, maybe the interest in blockchain-based DIDs has maybe gone back a little bit, or a lot of projects, like I said, seem to favor DID web for its simplicity. But personally, I do believe that for certain kinds of DIDs and certain use cases, a blockchain with the immutability aspects is a very good technological choice for a DID method, because of the immutability and history that you can see of the DID, and the fact that nobody can take the DID away from you, right? That is one of the whole original ideas of self-sovereign identity, independent existence, and so on. So the ability to create an identifier that only you control and nobody can delete it is, I think, still something very powerful, even if in the recently maybe blockchain is not anymore such a favorite choice always for DIDs and centralized identity. But if you look at it and trying to be objective and see the pros and the cons, then I think blockchain-based DIDs are also very valuable for some situations.
Looking at some of the projects that are happening in the European market right now, the last podcast I did was based on some of the advancements in the IDIS regulation with the 2.0, and also looking at the Europeans' digital identity wallet and architecture reference framework. Seems like there's a push for mobile driver's licenses in the recommendation, and also there seems to be some momentum behind the OpenID for verifiable credentials. And that's being proposed as a way of exchanging credentials between parties in the European architecture reference framework. I don't think that DIDs are used in these implementations. Can they be used? How do you see the future of DIDs in Europe? Do you see it as an alternative to these? It would be interesting for me to understand how you see that fitting within the direction that the European Union is going in.
I think that's not really decided yet. You're right that the current draft, I think, of the architecture reference framework, as far as I know, doesn't mention DIDs in a prominent way. But it's on one hand it's a draft document that can still change, and on the other hand it does mention certain technologies which don't depend on DIDs, but which are often used in conjunction with DIDs, right? So you mentioned OpenID Connect for verifiable credentials. That aligns and has a lot of synergies, I think, with DIDs, and the same is true for W3C verifiable credentials, which are also mentioned in the architecture reference framework. So I think it's undecided at this point. There may also be different implementations in the future of this architecture reference framework, different approaches, and it's I think still quite likely that DIDs will be used in some form. And it's also worthwhile to mention another important EU initiative besides the EU digital wallet and the architecture reference framework. There's also EPSI and ESIF, the European Blockchain Service Infrastructure and the European Self-Sovereign Identity Framework. And these initiatives are completely based on DIDs and verifiable credentials. EPSI itself is a DID method, right? So the EU Commission itself has put in place a blockchain infrastructure with nodes hosted in all the EU member states for creating DIDs, and there are dozens of pilot projects and use cases around digital diplomas and social security cards and some other things that use this EU-funded infrastructure, and there's I think also a lot more coming. So it's a bit hard to predict right now how exactly this will be implemented. There are several consortia and research projects that are getting funded now in the next few years to evolve and try out these architectures, the EU wallet. So I think we'll see a lot of development there, and I'm convinced that DIDs will play an important part.
Thanks for tuning in today. Hope you enjoyed the conversation as much as I did. To stay up to speed with future episodes, or to catch up on ones you may have missed, make sure to check out the SSI Orbit podcast on your favorite podcast platform, and make sure you subscribe. If you have any questions, comments, or wish to see someone in particular on a future episode, you can find me by searching Metzer Glode on LinkedIn or Twitter. Feel free to reach out to me directly and I'll get back to you. See you all next time.